Hi everyone and welcome again. In this episode, which is a very special episode again, uh, and it doesn't mean that I have deviated from my original series, which was about applied machine learning and the different episodes we were having building the ML framework. So there are many new episodes lined up, and they will be live shortly in this week and the following weeks. So what we are going to do in this episode is pretty interesting, and I always wanted to do that, is to code for a ongoing kaggle competition. And I've seen a lot of YouTube videos and tutorials, and they always focus on some playground competition, playground dataset, but none of them have ever touched an ongoing kaggle competition. So this competition is quite interesting, and it also has like a month left, so you can get a pretty good rank if you follow this video, and obviously you have to make your own modifications, so you have your own secret sauce. So let's start with this one. And the competition that we are going to do today is Bengali.AI, handwritten grapheme classification. So what's grapheme? Grapheme is the smallest unit in a written language. So Bengali has 49 letters and 11 vowels and 38 consonants, but there are also 18 accents or diacritics. Sorry. Um, so this results in more than 13,000 different grapheme variations. So I'm not an expert in this. So all that I've read is from this description here. So what we are going to do is we won't go into too much details of what it is. It looks like an image classification problem. So there is an image, and you classify into um, different classes, and it looks like from this picture that we have, it looks like there are 168 classes for one type, 11 classes for another type, and 7 classes for the third type. So let's look at the data that we have. So we see a number of files. There's some Parquet files, train image data Parquet, test image data Parquet. There is a train.csv file. So in train.csv, what we have is we have ID for an image, we have the grapheme root, vowel, and consonant, and you can see like it has different classes for grapheme and different classes for vowel, different classes for consonant. So looking at this, if you have seen my previous videos, it looks like what kind of problem? A multi-label classification problem. So it is a multi-label classification problem. And then you have class map. So class map is nothing but, okay, it says, okay, class label 0 is this component, class label 1 is this component for grapheme. And if you scroll down, keep scrolling down, keep scrolling down, keep scrolling down, yeah, after 167, so it starts from 0 to 167, so 168 total classes for grapheme. And then you have from 0 to 10 for vowel, different types of vowel, and 0 to 6, that is 7 classes for consonant. So clearly a multi-label classification problem. So let's see. So now, to start with this problem, as I've always mentioned previously in my previous videos and everywhere else, like what you want to do is first build a good cross validation system. So you need to build some kind of folds, because if you don't have good cross validation system, you don't know how good your model is, and you cannot just throw spaghetti at the wall and hope to stick. So you see there are some more details. uh, so the details are like each Parquet files contains tens of thousands of 137 cross 236. So 137 is the height and 236 is the width, grayscale images, and yeah, you have the class map. Okay, so starting with this, what we are going to do is first we are going to set up our workspace, and as usual, you see it's VS Code server. So what I'm going to do is, let's see, what do we have? So we don't have anything. I'm just gonna create some folders. So I'm going to create a folder called input. So that's for your input data, and I'm gonna create another folder. Okay, I'm not gonna create it here. So I'm gonna create another folder called source or src, and we need some more stuff. We need a gitignore. So gitignore will ignore all the files that I don't want to push to Git. So some files can be really huge. And then I'm gonna go to my terminal, and what I'm going to do here is I'm gonna go to my original repo and copy the gitignore. So I have the gitignore here, so I'm removing some Parquet files, CSV, numpy. So I've shown in my previous videos how to create this gitignore files, so you can take a look there. There's a lot more information that I don't need, like embeddings and all, cat boost info, but I've just kept it here for now. And then another thing that you need to do is, let's see what we have now. So we have input and source file. So I'll go to input, and okay, in the data for this competition, you have this command to download everything using Kaggle API. So if you're not familiar with Kaggle API, I recommend you to take a look. It's quite easy, and you can do everything in command line. So here I'm gonna run this command. Hopefully everything is set up properly, and it's going to download the data. So now it's downloading the data. You see it's quite huge, and in the meantime we can start writing some code. We don't need to wait for this to be over. We can just start writing some code. So let's write some code. And the first thing that we are going to do is to create folds. So we're going to see how we can create the folds. And we have already seen that this is a multi-label classification problem. So what that means is each and every sample has, here in this case, 3 different labels. So you can have multiple models. So you can have one model for Grapheme, one model for vowel, one model for consonant, or you can have a single model that predicts all these 3 classes. Now I'm not an expert in computer vision, so if I make some mistakes, let me know. I will start from writing the create folds. So to write create folds, we see that all our our data, the train.csv file, which contains all the labels, it's a CSV file obviously, and just to okay, now you can hopefully see everything in this terminal. Okay, so we have to read the CSV, so we need something, and that something is pandas. import pandas as pt, and then we will import so we have to do a multi-level classification. So for multi-level classification, there is a very good library. It's called iterstrat ml stratification stratifiers. Hopefully I will find, oh yeah, okay, yes, here it is. So this one, pretty good library. So it's for multi-level classification, and it has a class multi-level stratified k-fold. So that's like stratified k-fold from scikit-learn, but for multi-level. So we are going to use that, and let's see how this works. So from iterstrat.ml stratifiers, import multi-label stratified k-fold, and we have that, and then we write main underscore main, and you read the CSV pd.read CSV dot slash input slash train.csv. So this reads the CSV file into a pandas data frame, and you can also like do a small print just to make sure it's reading. It is obviously reading. And then what we do is we create one more column. So we create one column called k-fold and fill it with -1 for now. It's also a good idea to do some kind of shuffling of dataset. So I'm just going to shuffle the pandas data frame. So I'm going to say df.sample frac equal to 1. That's a fraction. What fraction of rows you want to sample, and reset index drop equal to true. So when you do this randomization of rows, it changes your indexes. We don't want to do that, so we reset the index. So now it has an image ID column, so I'm going to say df.image_id.values is my x and my y is df. Now here's the interesting part. Instead of one column, you have multiple columns. Grapheme underscore root, you have vowel underscore diacritic and consonant underscore diacritic, and we are going to convert it to a numpy array, right? So now you initialize the multi-label stratified k-fold class. So multi-label stratified k-fold is this one, and then define the number of splits. So n splits equal to 5. Let's say we are doing 5 folds. Now the next step is to go through this iterator MSKF and get the training and validation indices. So for fold comma training underscore comma validation underscore in enumerate, and then you have MSKF dot split x comma y. We got that. So I'm just gonna do a print train. So what's my training indices? trn underscore comma val. So what's my validation indices for every fold? It's just going to print that. It's like a simple check sanity check. df.lock, not even a sanity check, I just want to see what's happening. And then I'm going to fill kfold with the fold for validation indices. So that's very important, not for training indices, for validation indices. And then you can do print df.kfold not keyrefs, kfold.value counts, just to check. And then you can transfer it to a CSV. So I'm just gonna put it back in my input folder, train underscore folds.csv. I'm gonna say index is false. I don't need the index column. And this way we have created create folds, so that creates the folds for us. And here in the terminal you see that we are also done with the downloads of the data. So I'm just gonna unzip it. It's also gonna take a while, so it's unzipping all the data for me. So now how these Parquet files look like, it's very interesting. It's also a little bit weird. So in these Parquet files, what you have is a column called image ID, and then you have multiple columns for the pixels, image pixels. So we can take a look at that. So let's say I can just start a small terminal here too. Terminal, okay, so here it is. So here is my small terminal, or I can also do it using Jupyter Notebook. I think that's much better for this purpose. So I'm gonna go here and start Jupyter. Okay, let me fix that. Okay, let me fix that later. So I hope this is visible. Okay, so now it's good enough. Okay, so we have downloaded all the data. So you see, like, we have all the data files here, and now we can run our script that we have just created. So I'm going to the source folder. I'm gonna say Python create folds.py. I hope it runs. No, it doesn't. It throws an error. So there is some kind of invalid syntax. And where could it be? Okay, I'm missing a comma here. Okay, so let's run it again. Data frame object has no attribute value. Obviously, it's called values. And run it again. So you can see, like, it has printed the data frame, image ID, grapheme, vowel, consonant, and the grapheme itself. And now it's printing a lot of values, yeah, which looks good. And you see, like, every fold has 40,168 samples. So 5 folds, a little bit over 200,000 images. So that's a lot of images. And now what we can do is we can go to Jupyter. So let me start Jupyter. So this is my Jupyter lab, and I like it more than Jupyter notebooks because you have all the files and you can see everything. So I'm just gonna create a folder called notebooks here, and inside that I'm gonna create a notebook. Let's go here, inside this, let's rename it to check data frame. Okay, so we do import pandas as PD, We don't need anything else, I think. So that's good enough for us. And we need to read this Parquet file. So we have input slash, okay, let's read any training one. So let's see what we get. What is it called? So input ls train image data Parquet train image data 0 dot Parquet. Okay, so this doesn't read. Read Parquet pd.read Parquet. So does it have any problems? Train image data, it's here. What books? Let's see. Okay, what is happening? Where am I? Okay, I'm in the wrong folder. That's weird, because I moved the file. So looks like something is wrong with Jupyter. Well, let's try to refresh that. Okay, come here, import. Okay, let's just first check where am I. Still it's saying wrong folder, so let me fix that quickly. So I don't know why that happened, but I restarted the Jupyter lab and it's fine now. So import pandas as pd, and then you have the data frame, which is pd.read Parquet. So to read the Parquet file, you also need a package called pyarrow. So you can do pip install pyarrow, and otherwise this command is going to tell you that you need to do that. So input slash train. Oh, now I have it. So I read this one. So this is a huge file. It's going to take up some RAM and some time. So let's see how much time it takes. Should not be. Oh, it's quite fast. Okay, so I'll do a head on this, and you can see like you have image ID column and all the pixel values. So the image is 137 across 236, 137 into 236, and 32332. So it starts from 0, should go to 32331, and yeah, so that's what you have. It's a huge file. So I'm going to stop it and say okay, restart kernel and clear all the outputs. I don't need anything in my memory at the moment. So the next thing that we have to do now is to create another file. I will call it create image pickles.py. So why I'm doing this, because if you read from data frame, if you read the images from your data frame, it's going to be very slow all the time. So I'm going to read it from image pickles. Once you create the pickles, you can also upload it on GCP bucket and then use TPU training. You can also do it for data frame, but the problem is it's going to be super slow. So we are just going to create pickles for all images possible. So there are 200,000 images. We're going to create 200,000 image pickles. So I import pandas as pd, import numpy, just for the sake of it. Let's see if we use it. Import joblib. Okay. Do we need anything else? So we need to know what are the files. So import glob. So glob can list the files for us, and we need to see the progress. Import from tqdm, import tqdm. So we have all that. Now we can write the main of the script. So the first thing, we list all the files. So we can list all the files using glob.glob and input slash. So we need to list all the training files, and we can use wildcards in glob.parquet. So it's going to list me all the training files, as you can see in the terminal, like these ones. And then for each file in files, now I'm going to add tqdm files, and total is len of files. We are going to read this parquet file, pd.read parquet f, and we are going to create a image id array. Image ids is df.imageid.values, and we are now going to drop this image id column. So we can do df.drop image underscore id and define the axis. This is a column. And now we can do one more thing, call it image array. So now your data frame doesn't have the image id column, it has only the pixel values. So df.values, so that's your full array. We convert it to array because if you do data frame, it's going to be super slow. So now you can print a little bit of information here if you want, what is the shape of the array, but I'm not going to do that. So I'm just gonna say let's remove tqdm from here, we don't need it. So okay, so just remove this part. For j comma image id, now we add tqdm because this part is going to take much longer. So I want to know enumerate image ids and total. Here I always like to pass the total number of samples for tqdm, so that's equal to my length of image ids. So we have that, and now we can just do joblib dot dump image array, and you extract one image. So extract all the pixels of that image, and since I'm using Python 3.7, I can use fstring. So I will say // input / image pickles / name will be image id dot pickle, pkl, or whatever you want. So we have this now. So this is going to save all image vectors in image pickle directory, but we don't have the image pickle directory. So let's create it, image pickles. Okay, so we have written this thing, and we don't use numpy. I'm gonna remove that, and we just hope it works. So let's see if it does work. Python create image pickles. So we have created the folds file. We have the folds file now, and now we are going to create these image pickle files. So let's see if this works or not. Okay, so this seems to be working, and you can see it's super fast. So probably gonna take like 30-35 seconds for one file, and that's 40,000 images. So it's saving all these images on disk. So I'll have everything on disk. So I'm not going to show you because it's going to kill my computer, but it's everything is going to be in image pickle files, image pickle folder. So let's wait for this to finish now. Okay, so this has finished, and you can see we have already spent 30 minutes on the video, and all we have done till now is create folds and create the image pickle files. So things are going to move a little bit fast from here, so please pay attention. You see that my VS Code is also complaining now, so because of so many files it cannot keep track of them. Okay, so the next thing now, what we do is to think about the model itself. So in the beginning, I talked about how you can create 3 different models, train 3 different models for each and every class, or you can do one more thing. You can create a single model and predict all these 3 different classes. So doing a single model is much easier, and it's going to consume much less time to train. So that's what we are going to focus on. And the first thing that you would like to do is to create a dataset class, so where you get all items from your training dataset. So one thing that I forgot to mention, that we will be using PyTorch for this video. So I create a dataset class, and inside a file called dataset.py. So now to create the dataset class, what do we need? So we need to make it a little bit general, so that if you plan to change the model at some point, you can change it very easily using very few lines of code. So I say, okay, my name of my dataset class is Bengali dataset. Since it's training dataset, I'm gonna call it Bengali dataset train. And then you need to define a init function, so that has self, obviously, and it has folds. So folds will be something like folds is a list of numbers, fold 0, 1, 2, 3, or just one number if it's a validation fold. So you need image height, image width, and do we need anything else? So for image problems, we always need to normalize, so mean and standard deviation. So now you can here read the file, read CSV. Now no more read parquet, input /train_folds.csv. Great. So we have done this. To read the CSV, we import pandas. Okay, and you don't need everything because there's one more extra column called Grapheme in it. Yeah, I think so. I think it's called Grapheme, so you don't need that. So what you need is here image ID, and then you need Grapheme root vowel diacritic and consonant, and you need kfull column. Okay, so you have all that. Now this data frame consists of all the information about targets of all the images that you have, but for a particular run you need only certain folds. So let's filter that. So you can say I want data frame rows only where kfold is in folds. So you see that my folds was a list is between and has values from 0 to 5, and then I also reset the index just for the sake of it and drop it. And what you have self dot image IDs, your df dot image ID dot values, and then let's copy paste this thing. 1 2 3. Anything else? No. And df.grapheme root is grapheme root, df.vowel diacritic, this one, consonant is this one. So I've converted every column that I need to a numpy array. And I'm also gonna say self, no, this is wrong. Self dot image height is equal to height. Probably we don't need that. No, we don't need that. Let's leave it. Okay, so we have this one. Now what is your length of this dataset? How many samples do you have? So define the len self, and here you can just return the length of self dot image IDs. Okay, cool. So we got everything that we need till now, and you need the most important function called get item. So self and item index, which is a number from 0 to length of your dataset. And we say image is, now we can just load the pickle file. So image.load, I can use fstring input slash image pickles now, and then inside this I have self dot image IDs, which item, the item index dot pickle. So this is going to give me one image, and for this to work I also need to import joblib. Okay, great. So we got the image, but the image is the image is a vector, so we need to reshape the image. So image dot reshape to 137 and 236 dot as type float. So we just convert it to float and a 2D array because it's a one dimensional vector. And 137 236 is already given for this problem. All images is going to be of the same size, so you can just hard code it. The next thing that we will do is to convert this to a PIL image. So to convert to a PIL image, we need to import from PIL import image. Great. So we got that too. Image dot from array. So it converts a given numpy array to an image to a PIL image, sorry. And I'm gonna convert this to RGB image. So it's a grayscale image, single channel RGB, because most of the models that we are going to use, I mean all the models that we have pre-trained from Torch Vision or pre-trained models library, they all work on RGB, and I don't want to spend time making it work for single channel only. But you can do that. You can try doing that. Hopefully that works. So now we have almost everything, but we are missing something important. So I'm going to import another library here, import Augmentations. So that's your augmentation library, very good, very fast. And I'm going to write a new self.aug variable inside the init. So here we have you can do augmentations.compose, and then you can define not composed compose, and then you can define all kinds of augmentations you want. So we do this, and then we have to do it for training and validation set separately. You don't want to have augmentations and validation set unless you run it several times and average, do some kind of do some kind of TTA. So you have, I can say if the length of folds variable is 1, it means I'm in the validation phase. So I can do self dot, or I can just copy this part. I can do this here. Let's say this. Let me fix that. Okay, and here I will have a resize. So I have variables like image height and image width, these arguments, sorry. So I can just apply image height, you see, image width, and I'm gonna say always apply is true. Okay, we always resize. The second thing that you have to do is to normalize the image. Okay, so I'm gonna say mean std, and max pixel value is already set to 255. I don't need to do that, and always apply to true. Right, so we got this one, and now I'm gonna copy this part. Let's delete this. If my length of folds is not equal to 1, it means it's a training dataset. And for training dataset, we can do a little bit differently, or we can just keep the same. So just for the sake of doing something differently, we can include some kind of augmentations. I'm going to say, okay, I'll keep shift limit the same, 0.0625, scale limit to 0.1, and we don't want a lot of rotations, it's characters. Rotate limit to 5 degrees, let's say. Let me make it more readable. Okay, so we have this one and this one, and do we want anything else? We can have something like a probability when to apply this. So I can say apply it with a 0.9 probability. So 90% of the times it's applying this shift scale rotate, and forgot a comma. So we got that, and now what we can do is apply the augmentations. So it's very simple and easy. So I'm gonna say self image is self.aug image image equal to numpy array image, and then I'm gonna take image from the output. Okay, so this will apply augmentation on the image, and it's going to check if it's validation or if it's training, I also need to import numpy. Okay, and then I need to transpose the image to fit the torch vision models. So I'm just gonna exchange the RGB channels 201, and I can just for sanity check, I just convert it to a float. So we got everything that we need from this getItem function, and we can just now return it. So return image will be torch.tensor. So convert everything to tensor image, and type is torch.float. Okay, now you also need to return the targets. So Grapheme root will be self dot grapheme root, and that's also a numpy array. Okay, we also need to convert this to tensor grapheme root, and you extract given item, and the d type for this will be torch dot long. Yeah, that should be correct. Torch.tensor grapheme root and d type torch.long. And why I've done this part, take a look at how torch vision model expects the images. You will know. So we got grapheme root, and then we have two others, vowel and consonant. So I'm just gonna replace there, and consonant I'm gonna replace here. Okay, this is extra comma I don't need, but doesn't matter. But so now we are done with the dataset class. So reaching 1 hour, not even started with the model yet, and that worries me a little bit. So now the next part is to verify if your dataset class is working properly. Okay, and to do that, it's also quite simple and easy, and we will go back to our Jupyter lab to do that. Just see the models there. So after this, we have to define what kind of model we want to use, and we also have to define a training file, and the last step would be to create an inference file. So that shouldn't take long, the last step. Training probably a little bit longer. Let's see. Without wasting any time, let's see what we can do with visualization. So going back to Jupyter Lab, I create a new notebook. And here I import this. So this is going to add my source directory to the path, and then I can just import from dataset matplotlib.py plot as PLT. I need matplotlib to show the images. Do I need pandas? No, I don't need pandas. So I can just do matplotlib inline, show the images here. I can also import torch, and the most important thing is to import the dataset class, Bengali dataset train class. Okay, so I think that's just all I need. And if not, we will import later. So dataset is Bengali dataset train, and here you have folds. So I'm gonna say my folds are 0 and 1. You will always have 4 training folds and 1 validation fold, but in here I'm just saying 0 and 1. Image height, if you want to resize, I don't want to resize, so I'm just going to stick in the same numbers, the original height. Width is 236, and we also need mean and standard deviation, so mean for each channel. So this is pretty standard from ResNet. 0.456, sorry, ImageNet models. 0.406, and then you have standard deviation, which is, I don't remember, 0.225. I don't remember these values, I have just written them. Okay, this didn't work. Augmentations doesn't have compose, so we did something wrong. Spelling mistake. It's a capital C. So now I need to restart this kernel. Okay, and let's try it again. Okay, now it worked. So if I see my len of dataset, 80,000 images, 40,000 one fold. Yeah, okay, and I'm using 2 folds. So now I can just do idx0, 1 image, and image is dataset and idx. So that will give you the dictionary and image. And do I need anything else? No, I don't need anything else. But just for sanity check, what I can do is I can seize the Grapheme root and vowel diacritic and consonant diacritic, and then I convert it to a numpy image. I will say image.numpy, and then I can see the image .im show. Now we have to transpose back np image comma 1 2 0, and we can now see this image. Let's see, doesn't work. Torch is not defined, of course. So we forgot the most important thing, import torch. Okay, going back. Okay, let's run the steps again, and again we have a problem. Numpy is not defined. Okay, that's not a big problem. Import numpy snp, and here we go. See the image. So that's your image, 137 236, and you can just change it and see a different one. And this is giving you Grapheme root, vowel diacritic, consonant diacritic, and that's what you have to predict. So now finally we can move to creation of our training script. So we will create training and model a little bit in parallel. So let's start with that now.